Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from homework section 3.1. 3.1. Let's close that down a little bit. There we go. What's going on here is we got a big change. In this particular section, we're taking a look at systems of equations. And these are systems of linear equations with two variables. Okay, so linear equations mean we've got straight lines. Let me go all the way down to the bottom of this to some open space. I think I got some open space down here just to do a couple notes here. And I'm gonna write system of linear equations. And this is going to be just a 2 by 2, so that means two linear equations. So kind of want to know what kind of systems do we have here? Or let me ask, how many solutions can we have? If you have, so let's look at a couple different options. If you have two straight lines, right? How can they interact? Well, you could have, for instance, a line right there, right? And there's infinitely many different ways you can draw this, but one example is you've got two linear equations, and this point of intersection, didn't mean to put that on the x-intercept, but that point of intersection, x comma y, is the one point, because these are linear, it's the one point that works for the red and works for the blue. And the one point, x comma y, that when we put into both equations, I don't have the equations showing, but visually it's points that lie on our lines are x comma y values that make that equation true. So this x comma y value makes the blue true and the red true, so it's the solution to the system. So what different kind of solutions can we have? Well, we can have one solution, like in this case right here. So we've got one solution. Oops. We've got, man, that's all wrong. Try that again. One solution. There we go. So we've got one solution. That was really difficult. We've got one solution. What's another possibility when you have two straight lines, two linear equations? Well, there's infinitely many different ways you can make one solution. But can you make no solutions? Is it possible to have two lines that never touch? And for that to happen, you have to have two lines that have the same slope and different y-intercepts, because you see the fact that they have different y-intercepts, they've got different starting places and the same slope, they never cross. So therefore, since there's no point of intersection, this would be a no solution. Having trouble with writing solution here. This would be no solution visually, right? And I'll have to show you what that means. If you remember from Chapter 1, a no solution equation is when the x's and y's drop out and you have a false statement. But we'll go over that when we get to that one. This is the visual of what's going on. And then finally, you've got a situation where you have infinitely many solutions. So that sounds weird. How can you have infinitely many solutions? Well, it's one of these things where the two lines are written in different formats. They look like different equations, but if you solved for y, put them in slope-intercept form, you'd find out that they're the same exact line. So if I had a red line right there, and the blue line happened to be the same exact line as the red line, then how many places do they cross? They cross infinitely many places, infinitely many solutions. Okay, so that's kind of a big picture, I think, that you really want to get when you're doing systems of linear equations. There's three different types of answers: one solution, no solution, infinitely many solutions. When we get into consistent and independent, I think I want to talk about that because it kind of makes sense to talk about that right now. Basically, when they talk about a system that's consistent, basically, when we're talking about a consistent system, Consistent basically just means it has an answer. Inconsistent basically means it has no answer. So consistent, it has an answer. It might have one answer. It might have infinitely many answers, right? But it has an answer. Inconsistent means it has no answer. So if you go back with that information, if you go back to, let me use another color now. If you go back to take a look at these three situations, consistent means it has an answer. So this would be consistent. And no solution, this is inconsistent. And infinitely many solutions, well, it must be consistent. It's got an answer. Now, the next word that's used, so this is the next word that's used is to describe the system is dependent or independent. So dependent in English would just mean that the two lines or the two equations are the same thing. Both. So both equations are the same, and independent both equations are different. Okay, so let's go ahead and write that part up in green. So if I'm going to do the dependent-independent part, I go back here. This system is consistent, and there's two different equations, so they're independent. Or independent, consistent, however you want to say it. I just did it this way, independent. Are these equations different? Yes, they are, so it's independent. And are these two equations different? No, they're the same, so they're dependent. Consistent, dependent. So that kind of helps you. I think that helps with this consistent, inconsistent, independent, dependent. If you just kind of remember those, what it actually means in English. All right, well, I think we're ready to get started now. Let's get on up here to the first page. And here's the first page right there. All right, first question. Oh, let me make it a little larger. It says, which of the following points is a solution to the system? Okay, so once again, for this 1, 5, for that to be the solution to the system, it must work on the first equation and the second equation. Remember, it has to be a point on both equations, so it must make both equations true. So let's take a look at this first one. We're going to check. Now we want to do a check. We want to use the point 1, 5. This is our letter A, part A. So it must work with our first equation. So our first equation is 3 times x plus y must equal 8. So once again, I'm just going to put some values in here. I've got 1 for x and I've got 5 for y. And when I solve, 3 times 1 is 3. 3 plus 5 is 8. 8 equals 8. True. So 1, 5 is true for the first equation, but remember it has to be true for both equations. So now let's see what happens with the second equation. I'm looking at the second equation right there. That is negative 2 times x plus 4 times y equals 4. Now let's go ahead and grab our points. And we've got 1 is for x, and 5 is for y. Now we go ahead and simplify. Negative 2 times 1 is negative 2. 4 times 5 is 20. I add that up and I get, 18, which is definitely not equal to 4. So that is going to be a no. Yes, it worked for one point, but it's got to work for both points to be an answer, a solution. So then let's take a look at the next, let's take a look at the next problem here. And this is problem B. So we want to check for the point 2, 2. So I'm going to take my first equation, once again this guy right here, which says 3 times x plus y must equal 8. Go ahead in this case, grab those numbers, 2 for x and 2 for y. And when I solve, 3 times 2 is 6, plus 2 is 8. So 8 equals 8, check, it works for the first one. Let's see what happens on the next. What's the next one we're doing? Whoops, get it out of there. Next equation is the second equation in our system. Negative 2 times x plus 4 times y equals 4. So the values that I'm using here, I'm checking, is 2, 2 going to work for this one? It already worked for the first equation. Is it going to work for the second equation? Negative 2 times 2 is negative 4, and 4 times 2 is 8. And turns out that negative 4 and 8 makes positive 4, which is exactly what we need. So yes, 2, 2 worked for both. And so 2, 2 is, yes, a solution. Now let's check out the last possibility here. Taking a look here at, let's see, let me write down, check my last negative 1, negative 3. And some people might say something like, well, there can only be one solution. Well, you could have at most one solution. Well, not true though, right? You could have one solution, but what if those two lines were the same line, like my last example, my last situation where you have infinitely many solutions? It's actually possible to have a point not work, but have infinitely many points work, because infinitely many solutions doesn't mean all solutions are going to work. It just means you have infinitely many of them. Not every single point out there does work though. But so we do have to check this still. So let's go ahead and check it. That first equation was 3 times x plus y equals 8. Now we want to check it out. I'll only use a different color this time just to keep things sorted out. How about purple? Negative 1 goes in for x and negative 3 for y. That's a negative 3. And then so when I go ahead and simplify, 3 times negative 1 is negative 3 plus a negative 3, which gives me, plus a negative 3, which gives me negative 6 right away. That is not working, so it doesn't matter if the other one does work. This is not going to work because both have to work. So it's no. Negative 1, negative 3 is not a solution for that system. Okay, so that was kind of a pain, but on this particular problem, they gave us 3 possible solutions, and we had to check both equations for each one of those possibilities. Usually when we're solving these problems, we don't have the solution. We actually have to find them ourselves. Okay, let's see what's next. Fill in the blank. So this is kind of what I was talking about at the end of my little mini lecture. A system of equations that has no solution, is called, what kind of system has no solution? Is called inconsistent, right? Inconsistent system. Okay, let's take a look at, let's see. Okay, inconsistent system. So I kind of actually wanted to check and see a couple things and see how the system took in a couple answers, and I actually didn't do that. I think I'm going to keep on going since I already started this. So now, next question says, fill in the blanks. If a system of equations has infinitely many solutions, the system is said to be what? So if it has infinitely many solutions, first of all, consistent means that it has an answer, so it's consistent. and it has infinitely many solutions, so it's consistent, it has an answer. But if it has infinitely many solutions, that's the situation where both equations, and you got one equation there, and turns out when you graph the next equation, it happens to be the same exact line, right? So so are these dependent or independent? They're dependent. They're the same exact line, so they're dependent. All right, moving right along. True or false, when the lines in a system of equations are parallel, then the system is inconsistent. Okay, let's check it out. When you have two lines that happen to be parallel, that means there's going to be no solution if they're parallel. So if there's no solution, then first of all, it's going to be inconsistent. So when two lines in a system of equation are parallel, then the system is inconsistent and has no solution. That's true. Inconsistent and has no solution. I'd say true on that. Okay, next up, we're going to go ahead and solve the system by graphing. I think what I want to do is use some color here. Let me do my first one in red. And this is beautiful because it's already in slope-intercept form. So that means we start at 3 is my y-intercept. And my slope right here, I'll go ahead and write it out, is 2 over 1, which means up 2 and right 1. So I go up 1, 2, right 1, up 1, 2, and right 1, up 1, 2, and right 1. So then when I go ahead and make this line, I could do so like that. And so there's my linear equation. There's my line. Now let me do the second one in green. And the second one is also awesome because it's already in slope-intercept form. It says the y-intercept is 7. So I go up here to 7. There's 7. And it has a slope of negative 2 over 1. That means go down 2 and right 1. So I'm going to go down 1, 2, right 1. Oh, nice. There it is. 1, 2, right 1. So right away you can see the solution to this already. So there's the equation of my line. And the solution is the point of intersection, and that is right there, which is 1, 5. Solution is 1, 5. And so that's A. Now, once again, if you had time, this is not required, but if you had time on the test, you could know for sure if this is going to work by simply plugging in a 1 for x and a 5 for y just to see if it's going to work. Let's do that real quick. I think I'm going to use some purple colors to do that. And I don't have a lot of space, so I'm just going to do a little bit of work right here. So if I put, in fact, I'm going to make this small because I really don't have much space. But my answer that I got was 1, 5. So what happens if I put in a 1 here and a 5 for y? Well, 2 times 1 is 2, and 2 plus 3 is 5, so that checked out. What if I try 1, 5 for this guy? Put a 1 in for x and a 5 for y. Is it true? Well, negative 2 times 1 is negative 2, and negative 2 plus 7 is 5. Check. And so, yeah, they both do work, so we know for sure that that is true. That will work. So moving on to our next equation, our next one. Let's see, I'm going to use red. The next one, the thing that's a pain about the next one a little bit is that it's not in slope-intercept form. However, that's something that we can still put it in slope-intercept form. It doesn't say you have to use slope-intercept form. You can use x and y intercepts, but I think often people really get into slope-intercept form and they get really used to it. So let's go ahead and do that. So I'm going to subtract 3x off of both sides. Oops, 3x, and then that's going to give me y equals negative 3x plus 2. There's my first equation. Let's go ahead and graph that one. And I could better zoom back. So my y-intercept is 2, so I go up to 2, 1, 2. Oops. Go up to 2, Put a little dot there. Let's make this a little bit of a bigger line. Up to, and then the slope is -3, so that means go down 1, 2, 3. It's too small. Go down 1, 2, 3, and right 1. 1, 2, 3, and right 1. 1, 2, 3, and right 1. So when we go ahead and graph this, come on, hit it. Oh, it's not snapping to, which that means I got to be much more careful if it doesn't snap to. Got a dog barking in the background. That's great. Got a bunch of teenagers in the house. No one will notice, of course. And I ain't stopping because I'm lecturing. Okay, so anyways, here's the line. There's the line right there. And want to see where is the other one going to cross, because the point of intersection will be the solution. So what I'm going to do is I'm going to subtract 3x off of both sides, which is going to give me -2y equals -3x plus 14. Divide both sides by -2, -2, and we end up getting y, I don't know if you can hear the dog barking, y equals negative divided by negative is 3/2 x minus 7. So we go down here to -7. And it says go up 3 and right 2. So we go up 1, 2, 3 and right 2. Perfect. 1, 2, 3 and right. Whoops. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So there's that. So we go ahead and finish that, and we can see the point of intersection happens to be right here at 2, -4. And that's the solution, 2, -4. Let's move on to the next one. The next one sort of gives us a step-by-step kind of situation to try to help us see how to do this. It's solving the system of equations by substitution. Now, the way you do substitution in general is you solve for x or y for one of the equations and substitute that into the other one. Now, this one is stepping us through and asking us to solve for x on this bottom equation. And you can see that that is, oh man, I'm gonna have to tell somebody to get the dog. Hold on 1 second, I'll be right back. This is awkward. Guys, I'm lecturing. Get the dog. Get the dog. I'm lecturing. She's like whining forever. Okay, that was a great use of the video. Finally got a teenager to respond. And so here we are. So what's going to happen here is they're asking us to, so basically what you want to do is you want to take either equation 1 or equation 2 and solve for x or for y. Now they're sort of spoon feeding us through this one and making us take equation number 2, as you can see right there, which is actually an awesome idea, because equation 2 has x already not isolated, but it's 1x, which makes it very easy to solve for. So what they're asking us to do is they're saying, how about if you take this equation number 2 right up here, right, and subtract 5y from both sides. Okay, well, if I subtract 5y from both sides, you can see there's not a lot of space here. If I subtract 5y from both sides, I'm going to get x equals -5y. Okay, so once I get that, x equals negative 5y, now the next step is to substitute. So the logic here is this. It's saying if you believe that x is the same as negative 5y, and it says equal, so it must be the same, then what we want to do is we want to go back. Now, we used equation number 2, so don't go back and plug equation 2 back into equation 2. That's not going to work. But used equation 2, so we need to plug it back into equation 1, and we're saying x is the same as negative, right, 5y. So we're going to replace this x right here with negative 5y. That goes in for x right there. So our new equation, and they're having us do it right down here, so you can see the coloring goes right here. Because you can see this equation we're subbing into says 2x minus 2y equals 6. Well, there's 2, and then whatever x is goes there, minus 2y equals 6. So this is just 2 times negative 5y, right? That just replaced the x. Okay. In fact, we're going to go ahead and try to use some colors to make that clear. This x right here got replaced with negative 5y. So what did that do for us? Well, that gave us now an equation. Notice we have an equation that only has y's in it, no more x's. And so when we have one equation with one kind of variable, it's easy for us to solve it. So now we go ahead and multiply, and they're giving us step by step, multiply 2 times negative 5y, and we're not introducing the 2. It's already here, right here, right? It's already right. Come on, pen. It's already right here. So now 2 times negative 5y is negative 10y. And they want us to combine like terms next step. So a negative 10y and negative 10y minus 2y is negative 12y. And then they want us to, next thing, divide both sides by negative 12 because we're solving for y. So we divide both sides by negative 12. And that gives us y equals 6 divided by negative 12 is negative half. Okay, so our answer, so it says substitute negative half for y in the equation in step 1 and simplify. So technically, now we're saying that y is the same as negative half. So technically we can go back to the original equation and we can plug y into either equation. Either one will work. But you might as well pick the one that's easiest, which looks like this guy right here, right? So we're going to plug in our answer of negative half in for that y in equation number 1. And actually they grabbed equation 1 after it was already simplified right here. Notice equation number 2 was already simplified right here as x equals negative 5y. And so they just grabbed that one. And, I think this process, for me at least, teaching it is almost easier just to not have all these little steps and just do it. It seems to, I think it would flow better, but I'll do some of those for you as well. Substitute, because we know that y is the same as negative half, we take our y and substitute negative half in for it. And then we multiply that together, and negative half times negative 5 is going to give us positive 5 halves. Pretty sure, and in fact I checked it before, that MyMathLab accepts improper fractions, but also it does want you to reduce. This is reduced, but it's improper, or you could put it in as a mixed number. So anyways, the solution to this problem, so let me write down the solution. The solution, the point that works for both equations, and we have it right here, x equals 5 halves, and y equals negative half. So now they're saying, hey, check it. Now, checking comes down to, do you have time, right, on a test? And if you do have time to check it, it's awesome to check it. How do you check it? You take your first equation, which was right back here. Remember, just like we did on problem number 1, see if that's true. If that's true, then see if the second one's true. And if they're both true with those points, then you know you have a solution. So what are the 2 points we got to check? Well, it's 1 point, but it's an ordered pair. So x is 5/2 and y is -1/2. So when we go ahead and check this, let me zoom in. I'm going to use a smaller pen size. So when we multiply 5/2 times 2, we just get 5, and there it is right there. And when we multiply, where'd it go? -2 times -1/2, we end up getting a +1, and there it is right there. And 5 plus 1 is 6, and so true. So far, we're good, right? Our solution of 5/2, -1/2 worked for the first equation. And they put this so close, it is really a pain because it looks like it's like one big equation. But this is, now we're supposed to check our next equation. So remember our second equation, let's see. So this is our solution right here that we're checking. This is so crammed, it makes it hard to see what's going on. So let's see, our second equation happened to be this guy right here, right? It was just x plus 5y equals 0. And so that's right here. That's this guy right here. X plus 5 times y equals 0. And this is horrible, at least when I printed it, horrible spacing. So it makes it so hard to see what's going on. Anyhow, we need to put our x value in, which we know we got 5/2, and our y value in, which we know we got -1/2. And 5/2, right? There's nothing to multiply that one by. But 5 times -1/2 makes -5/2. And 5/2 minus 5/2 makes a 0, and that's here. We got it right there, right? So that makes it true. So we know that the answer for sure is 5/2, -1/2. Like I said, having it like that, I don't know, that I think made it almost more complicated in some ways. Let's see how much space I have to fit this in here. And I think I've got enough space here. Number 8. Yeah, if I go like that. So here, let me say this the way I would say it. Okay, now, first of all, you have quite a few different ways to do this. Essentially what you're trying to do is you're trying to solve for x or y on the first or second equation. Let's call this equation number 1 and call this equation number 2. Now, I would like to do the easiest way of doing it, right? Wouldn't you want to do the easiest path? And some people don't. That's whatever they see is what they see, and that's okay, just as long as you follow the rules. And the rules are solve for x or y with the first equation or second equation. I'm going to pick 2 because 2 is already solved for. So, I mean, the work is already there. So what 2 says is it says y equals 3x plus 8. Well, if y equals that, can't I replace this y with 3x plus 8? And the answer is yes, you can. And the reason why you do that, let's go ahead and write that up here. The reason why you can, so I'm going to copy equation 1. Equation 1 just said x plus 3 times y equals 4, right? And this is just supposed to be, that's not a negative sign. So, right? Isn't that what it says? That's what equation number 1 says. But what did we just say? We just said, hey, I know what y is. Y equals the same thing as 3x plus 8. So I'm going to replace y with 3x plus 8. And now what we have just done legally, we have a new equation that only has x's in it, which means I can solve an equation with one variable in it. So I distribute my 3. 3 times 3x is 9x. And I distribute 3 times 8 is 24. And I combine my like terms, so that is 10x plus 24 equals 4. and I'm going to be challenged for space. So I'm going to subtract 24 off both sides, and I'm going to have to show my work over here. This is going to give me 10x equals negative 20. Divide by 10, and x equals, right? Divide by 10. What's negative 20 divided by 10? That's negative 2. So I just got my x value is negative 2. So I got my x answer already, negative 2. To solve the system, use substitution. Oh, they're not asking for the answer there. They're asking for the answer goes right here. So this one's negative 2. They asked to solve the system using substitution, substitute what in for y? And the easiest one to do would be this guy. Substitute 3x plus 8 for y. Now, technically, you could have solved for x or y on equation 1, and that could also work for you. But that's probably the easiest one to use is because it's already solved for y. Now, let's see, how do we get the y value? Well, to get the y value, let me just take this equation number 2, right? Equation number 2 right here. What's equation number 2? Equation number 2 just said y equals 3 times x plus 8. Wait, do we know what x is? Yes, we do. We already solved for x. X is negative 2. So I'm going to now replace that x with what? With a negative 2, because we already know x is negative 2. 3 times negative 2 is negative 6, and negative 6 plus 8 gives us y equals 2. So we get the answer of negative 2, 2. And you could always go back and check in the original pair if you'd like. You don't have to do it every time, but I guess I'll model that because it's not a bad thing to do. Remember, I got x equals negative 2 and I got y equals 2. So let me just kind of quickly show this. If I put in a negative 2 for x, and I put in a 2 for y, notice what I'm going to get. I'm going to get 3 times 2 gives me 6. What's negative 2 plus 6? Negative 2 plus 6 equals 4. And that's what's supposed to be on the right-hand side. And then for the other equation, let me get rid of some of this stuff that's in my way. Once again, negative 2 goes in for x, and positive 2 goes in for y. And we want to see what happens. Well, 3 times negative 2 gives me negative 6. And negative 6 plus 8 is 2, which is exactly what it should be on the left-hand side of the equation. So we've just proved that negative 2, 2 is definitely the solution. Okay, moving on. It says solve the system by using substitution. Okay, here we go again. We got a little space on the bottom, which is awesome. I'm going to go ahead and copy this down right here. So the system of equation is 4x plus 6y equals 20. And the second equation is negative 3x plus y equals 7. There's my system. I'm going to call this equation number 1. I'm going to call this equation number 2 so I can refer back to those. You want to solve for x or y on equation 1 or 2. Some people might say 1, and they want to solve for x. They might want to solve for y, but I say take equation number 2 because equation number 2 already has y, 1y. So it's going to make solving for y really quick and easy. So I can take equation number 2, negative 3x plus y equals 7. I could add 3x to both sides, and that gives me y equals 3x plus 7. So essentially what I'm going to do, right, is, well, if y is the same as 3x plus 7, well, now don't put this back into the same equation you're working. Notice where our work comes from equation number 2. You must substitute into the other equation that you didn't use, which if we know that y is the same as 3x plus 7, well, then we're going to replace that y with 3x plus 7. So now we're going to rewrite this guy right here as 4x plus 6 times, remember the blob? What's the blob that we found? Y equals 3x plus 7. And then finishing out this equation, it says equals 20. Once again, what this did for us, let's go ahead and simplify. 4x, 6 times 3x gives us 18x, and 6 times 7 gives us 42. What this did for us is it turned an equation that had, look at x, equation that had x and y in it, and my new equation over here now has only x's in it, which means I could simplify that and solve for x. 4x plus 18x gives me 22x plus 42. Subtract 42 from both sides, and this is going to give me 22x equals negative 22. Divide both sides by 22, therefore x equals negative 1. I've got my x. Of course, getting the y is easy because you can substitute it back into this equation right here, right? Unless you made a mistake getting there, but if you made a mistake getting there, everything's a big mistake. So the only way you know at the end is by checking it, right? So let's go ahead and say y equals 3 times x plus 7, and we found out that that x value happens to be negative 1. So we're going to replace x with negative 1, and then we're just going to simplify and we'll get our y value. 3 times negative 1 is negative 3 plus 7 gives us 4. So y equals 4. So we just got our answer, negative 1 comma 4. Answer negative 1 comma 4. To solve the system using substitution, substitute in, and I picked the easiest one, and this is where I meant to put these answers into. So far I put all answers back in as I solved these answers. I went ahead and put them back into MyLab just so I can tell you if something weird is happening or some kind of notation thing. But I forgot to do that, and then I started lecturing, and I can't stop now. So anyhow, I'm curious if they would allow us to use different types of substitutions, because technically you could use anything to sub, x or y in first equation or second equation. But this would be the most obvious one to use, because once again, we'll go to green. This would be the most obvious to use because it's so easy to solve for y. So that's what I'm going to write down. I use 3x plus 7 to sub in for y. 3x plus 7. So solve the system of equations using substitution. Substitute 3x plus y for y, and that's what I did. Okay, and that's what most people do because it's the easiest. It's easiest to solve for because it's already 1y. Okay, moving right along here. That was negative 1 comma 4. Let's go to the next one, which is asking us to solve by elimination. Now this is our third technique for solving equations. The first technique was graphing them. Where do they cross? That's a solution. Second technique is an algebraic technique, which is called substitution. That's where you solve for x or y, sub into the other equation, and simplify. This third technique is called solving by elimination, because you're going to eliminate x or y, and this is also, in some books, we'll call it solve by addition. That's another name for this technique, because you're going to add the two equations up. Okay, so if I were to add these two equations up, the interesting thing, if I had a nice big Desmos graphing calculator right now to show you, the interesting thing to me, at least when I first found this out, is that when you add these up, look at what I'm going to add. I'm going to add up vertically, like in grade school, except you would never do, you wouldn't have these kind of problems when you're in elementary school. But if you added them up, 1x plus 3x is 4x, 6y plus 3y is 9y, and negative 31 plus 12 gives us, what does that give us? A negative, is it 19? I'm drawing a blank all of a sudden. Yeah. So the interesting thing about this is this new equation actually goes through the answer also, just like these two equations goes through the answer, meaning goes to the point where the two lines cross. So that means this new equation can also be used to try to find that answer. So that's kind of a shocker and kind of a neat thing. But when we're using elimination addition, you want to eliminate an x or y when you add the two equations up. And notice when I add the two equations up, I still have an x, I still have a y. So really, I'm not in any better condition. Remember, with the last technique with substitution, we did the substitution for one main reason, is because our new equation only had one variable. And that's the same thing with this technique. We want our new equation to only have one variable. And I added up the two equations, and I got a new equation with the same two variables, so I'm not really in any better shape. So what you want to do here is you want to sort of massage or work the problem, get it set up to when you add the two equations, something's going to drop out, x or y. So something just I think I'm going to highlight a little more because they've got us doing these baby steps here, spoon feeding step 1, step 2, and so on. But I want to kind of talk through it myself here a little bit. And that would be, if you wanted the x's to eliminate out when you add the two equations, this x would have to be -3, right? Because +3 and -3 would be 0 and it would eliminate. Okay? You might ask, how can I legally do that? Well, if you multiply -3 on both sides of the equation, you would legally set it up to do that. Okay? Now, if you wanted the y's to drop out, which is going to be, it's probably easier to get the x's to drop out in this case, you'd want these to be, they're called additive inverses, you want them to be opposite. Well, this is already 6y. You'd want to multiply the bottom equation by -2 to make that -6y, and then they would drop out. Now, you don't need to do both of them. All you need to do is have one variable drop out, and then you're just going to use substitution from then to go to the next step. But that's what I want you to see here. If you want to eliminate the x values, you need to make one of them 3 and one of them -3. Well, this is already +3. That means I need to multiply this top number 1 equation by -3. And of course, you've got to do it on both sides, otherwise it won't be true, right? What do you do to one side? You must do to both sides. So that's what we're going to do, and they're going to give us the step-by-step here. It says multiply both sides by -3, and you can see that's what I came to on my own up here. So multiply both sides by -3. This is my left side, and parenthesis, and then this is my right side, -3. So when I do that, I end up getting, now this one we just copied down right here. So when I do that, I distribute -3 times x gives me -3x, and -3 times 6y gives me plus 18y. Okay. Oh, I take that back. Little mistake there. A negative times a, no? Yep. A negative times a positive makes a negative. There we go. -18y. Okay, so now it says use the distributive property. That's what I just did, right? I distributed using the distributive property to get to that line. Then step 2 right here, step 2, it says add equations 1 and 2 together. Now you're only going to do this if it benefits you, and notice it's going to benefit us because when I add -3x and +3x, I get 0x. So I get a 0 for that. And that's where the elimination happens. We just eliminated x's, and now we got equation with just y's. Now we got -18y, that's right here, -18y plus +3y. That's going to give me, let me zoom in, that's going to give me -15y. And on the right-hand side of the equation, I've got 93 plus 12, which gives me 105. All right. See where I'm at. Okay, so now the next step, it's asking us to please divide both sides by -15 rather. So I divide both sides by negative 15. And negative 15 divided by negative 15 gives us that 1y. And then 105 divided by negative 15, that gives us negative, let's see, 105 divided by negative 15 is negative 7. So now what we have here, I'm going to use another color. Now what we have here is we have the situation that says y is the same as, right, y equals negative 7. So y is the same as negative 7. So now, after we've done our addition elimination, the next step is just do substitution to finish it off. So notice my equation 1 is right here. Let's see, wait, let me go back to make sure I'm not lying. Where'd we go? Equation 1 was x plus 6y equals, equation 1 is right there, x plus 6y. So they've got equation 1 right here, x plus 6y equals, whoops, come on, equals negative 31. So remember, what do we find? We found out that y is the same as negative 7. So we're going to replace y right here with right in there, which is just negative 7. Okay, now we just need to multiply. What is 6 times negative 7? Well, that's negative 42. And then once again, it's kind of spoon feeding us the steps here. So it says add 42 on both sides. Well, you see why, right? Because we're trying to solve for x. So we add 42 on both sides. And when we do that, we get our answer, x equals 11. So we got y equals negative 7 and x equals 11. They want to verify that 11 comma negative 7 satisfies this equation by checking it. So let's go ahead and do that with them. So equation number 1, do they have equation 2 right there? Okay, I see. So let me do some highlighting here, just so eyeballs could find what's happening. Equation number 1, the first equation we want to check is right there. Now remember, we want to check our answer, which is 11 comma negative 7. So 11 goes in for x, and negative 7 goes in for y. So 6 times negative 11 gives me the negative 42. And 11 minus 42 is negative 31, which was the same as the right side, so that checks out. Let's now check our second equation, which I will use a blue pen on. And our second equation is right there. And once again, we want to put in 11 for the x value. We want to put in a negative 7, I believe, for the y value. And so 3 times negative 11 gives us the 33. And 3 times a negative 7 gives us a minus 21. And 33 minus 21 gives us 12, which makes this true. So it turns out the system of equations, the answer is 11 comma negative 7. Okay, so that was our first attempt at addition elimination. Let's do the next one, also doing elimination. And this says 7x. Let me see if I got space. I think I added an extra piece of paper to do this one because space-wise is not great. So let's do that first. This is going to be number 11 that I'm going to do on this open sheet of paper. And let me get a black pen. This is number 11. Number 11, it says 7x, the system 7x plus 4y equals 23. And the second equation is negative 2x plus 3y. And that equals negative 19. Now there's my system. That was a horrible brace I just made there. Let me try that again. Okay, so there's my system. So it says solve the following system by using elimination, also known as addition. Now you can see, so this one's a trickier one. You can see that if I just decided to add these two up right now, I would have 7 and a negative 2 is 5x, and 4y plus 3y is 7y. And the thing is, it's not going to help me because I did not eliminate an x or y. So we need to do some setup before we actually start adding these together. So the way you know, so let me call it a target number. Let's do that. So I'm going to call this a target number. And the way you find your target number is technically it's called a least, well, you want the two numbers to be additive inverse, which means opposites. But if you have a 7, right, a 7 and a -2, how are you going to make them opposites? Well, it's called a least common denominator. Actually, it's called a least common multiple, but it's the same thing as the least common denominator. What would be the least common multiple of a 7 and a 2? Well, that would be 14, the number that both of those numbers go into. So 14 would be the target number because 7 and 2 both go into 14, and you'd want to make one of them -14 and the other one +14. So that would be a great way to go. But because I want to tell you the full picture, it would be just fine if someone said, I want to eliminate the y's. Well, what would be the target number if you had a 4 and 3? And remember, it's your least common multiple. Well, 12, right, is the smallest number. So that means I can make one of these lines a -12 and one of them a +12. It doesn't matter which one you do, but you do want to know what the target number is, which is a least common multiple. Okay, so let's just go with our first option, which was let's go ahead and eliminate our x's, which just basically means I want to figure out what makes a target number of 14. So the question is, what do I multiply equation number 1 by? I'll call that 1 and this one's 2. To make this lead 7 in red a +14. Well, I'm going to need to multiply. I'm going to use some color here to show it. I need to multiply this top equation by 2. Why 2? Because 2 times 7 is 14. Now make sure you do both sides. So what's my new equation? My new equation is 2 times 7x is 14x. 2 times 4y is 8y. And 2 times 23 gives me 46. So now the next thing that I need to do here is I need to make sure that this next value, it says -2, I need to make that the opposite of 14. It needs to be -14. So how do I turn that into a -14? Well, if I multiply this by 7 times -2x, I get -14. So multiply the left by 7 and the right by 7. So, and let me see, what this is number 11, right? Where did I put this guy here? Anyhow, so now I multiply by 7. I think I'm going to grab a calculator on that. I believe it's -133, but I'll make sure I'm not going to make a mistake. So let's first distribute. 7 times -2. 7 times -2x is -14x. And 7 times 3 gives me +21y. And -19 times 7, -19 times 7, I'm just double checking, yeah, is -133. That's what I said, I just want to make sure, -133. So now, the beauty of this is that we've got it set up for something that really has to happen, otherwise you're not going to eliminate anything, and that is we've got these opposite numbers here. So now when I add the two equations up, I get 0x, and that's what I wanted to happen, and I've got 8 plus 21, which gives me 29y, and -33 plus 46, and that's going to give me -87. So now I divide both sides by 29, and y equals -3. I got my y value. Now I need my x value. And the way you get your x value is you just substitute it into equation 1 or 2. It's totally up to you which one you pick. They both will give you the same answer. So I can't remember which one I subbed it in for. I took, I think, equation number 2. So let's go ahead and do that. Now remember, equation number 2, I'm just going to write it down again. The original equation number 2 was negative 2x plus 3y equals negative 19. So now what I'm going to do is I'm going to take, if y, whoops, come on thing, it says y is the same as negative 3. So I'm going to replace y with negative 3. So now I've got negative 2x plus 3 times y, which is negative 3, equals negative 19. So now I've got negative 2x minus 9 equals negative 19. I go ahead and add 9 to both sides. Got negative 2x equals negative 10. Divide by negative 2. And x equals 5. Yay! I've got my x and I've got my y. So the solution to the system is 5 comma negative 3. You could always throw it back in to check it out. I think we're just going to move on. So let me answer the question back here at the problem. Not like I've got to put this in or anything. But the solution is 5 comma negative 3. It says obtain an equation in one variable by eliminating the x. So they asked us specifically, and I'm telling you, you have the option, but because it's a computer program, they're forcing you to eliminate the x, which that's what we did anyways. Perfect, right? Didn't we eliminate the x? We did eliminate the x. We eliminated the x right there, right? To where we had no x. Okay, so that's what we did. So then what do they ask us to do here? Obtain an equation in one variable by eliminating the x. That's what we did. Type an equation. Do not simplify. Do not evaluate. Type the equation where we eliminate the x. Okay. This is where I wish I would have remembered to put it in the computer just so I could speak to anything, notation-wise. But our new equation that we put in, let me highlight that with a highlighter pen. Let's go ahead and do that in orange. So after we eliminated the x, we got this equation right here. That's what they want us to put in up here. So that's, without simplifying, they said, so that's 29y equals negative 87. 29y, right here. 29y equals negative 87, right? 29y equals negative 87, yeah. Okay, and I will go back and plug some of these back in just to double check and maybe throw out a message if something looks strange. But that's what they're looking for there. Okay, so we got that answer. Let's look at number 12. Number 12 says, show that the system is inconsistent. What the heck does inconsistent mean? Inconsistent means that there's no solution. Well, I'm just going to do a quick sketch. I don't know what these graph out to, but if there's no solution, what that means is it means one of the graphs might be something like that, but the other one has to be parallel because it's only parallel lines that makes inconsistent solution, which means no solution, right? So they're asking us, show that the system is inconsistent, draw a graph to support your results. Okay. So use a graphing tool. Show that the system is inconsistent, draw a graph to support your results. Okay, so we're doing this by graphing. I guess when I did this problem, I went ahead and did elimination, and then I graphed it. No, that's fine. We just graph it. Okay, so let's go ahead and graph this. Let me take this problem down and have some space to operate. So let's go down here and call this number 12. So this is number 12. So number 12, it says negative 6x plus y equals 12, and 18x minus 3y equals 18. There's the system. We need to graph them. Now graphing, you have your choice because it doesn't say how to graph it. You could get XY intercepts, you could plot points. Most people at this stage tend to like to put it in slope intercept form because they're so fast at graphing it in that form. So let's go ahead and follow that. So if I want to put this in slope-intercept form, let me go ahead and do this one in red. And I'm just going to go ahead and rewrite here and then put it in. So I'm going to rewrite negative 6x plus y equals 12. Well, in order to put it in slope-intercept form, I got to add 6x to both sides. And there we are, we're already there. So that was beautiful. So now we've got y equals 6x plus 12. Y equals 6x plus 12. So my first one in red is y equals 6x plus 12. Let's get our second equation. So this was the one we did right here in red. Our second equation, that's supposed to be a box, we'll do in green. So we need to take this guy and solve for y. Put it in slope-intercept form, solve for y. I'm going to subtract 18x from both sides. This gives me negative 3y equals negative 18x plus 18. Divide by negative 3. Now these are not inequalities, so there's no flipping of anything because it's an equation. So now we get y equals negative 18 divided by negative 3 is positive 6x, and 18 divided by negative 3 is a negative 6. So now we have y equals 6x minus 6. Y equals 6x minus 6. So now, if you're sort of paying attention, you will notice that this is definitely going to produce an inconsistent system, meaning it's not going to have a solution. Why is that? Because look at the look at the slopes. They're both 6. So that means these two lines are parallel as long as they got different starting points, and they do. One starts at negative 6, the other one starts at 12. So let's go ahead and support that they're inconsistent by graphing it. So let's do the first one in red. And the first one in red says it has a y-intercept at 12. So we go up here at 12. And it says that it has a slope of up 6, right? 6 over 1, which means up 6, right 1. Being that going up 6, 1, 2, 3, 4, 5, 6 gets us off the graph, what's equivalent is negative 6 over negative 1, because a negative divided by negative is still positive 6, right? Which means go down 6 and left 1, which gets us the same line. Let me try to show that to you. Go up 1. So the first one I did right here said go up 6. 1, 2, 3, 4, 5, 6. And then right 1. I didn't like that because it took me off the graph. So I said, how about if we just go down 6? 1, 2, 3, 4, 5, 6, and left 1. 1, 2, 3, 4, 5, 6, and left 1. And so I've got my graph now. Let's go ahead and make that graph by going like this and going like this. Hey, I actually did pretty good there. Look at it, it goes right through that point, even though I didn't have graph paper there. So there's my red line, and I want to show that these guys will never cross. And so I'll do the next one in green, and the next one has a y-intercept at negative 6, which is right here. And it has the same slope of up 6, right 1. So let's zoom in. Up 1, 2, 3, 4, 5, 6, right 1. 1, 2, 3, 4, 5, 6, right 1. So now when I go to connect these points, I've got this kind of thing going on. That didn't work. Try again. It's supposed to be this sort of snap to function. Come on. If it doesn't snap to, my line is, I gotta really be careful how I draw this line. Let me try one more time. Okay. So I got to be careful. So I draw the rest of this line. It looks like this. And there it is. Okay, so here you can see the two lines are parallel and they're not the same line. Okay, so there's going to be no solution. It's called inconsistent. Let's see if we could figure out which one to select, which one applies. Choose the correct answer. The first one right here says, a system of two linear equations containing two variables always has at least one solution. Therefore, the system is, but always has at least one solution. Well, inconsistent means it doesn't have a solution. So we know that's, I mean, that's contradicting itself right there. Solving the system, I mean, you cross that off without even seeing any work because it's just not true. Solving the system of equations results in one solution. Therefore, the system is inconsistent. Once again, inconsistent system means no solution. So that's gone. Solving the system now, so it's not A, it's not B, now we're looking at C. Solving the system of equations results in a false statement, therefore the system is inconsistent. Ooh, actually that's sounding pretty good, but we actually didn't solve the system. So maybe I better solve the system. I just graphed it to show that they're inconsistent. Part D says solving the system of equations results in a true statement, therefore the system is, no. So that's totally wrong. So C is the correct answer, but you know, they're referring to actually solving it, not graphing it. Graphing it, I guess. So show that they're inconsistent by graphing it to support your result. So we're going to have to actually solve this system algebraically, and then our graph helps us confirm that there's no solution. So I need to go down here and actually solve this algebraically. So this is number 12. I don't have a lot of space now, do I? So now when you solve it algebraically, remember you have you got two different ways to do it. You could do it either by substitution or by elimination. So this is going to be number 12 again, but now I'm actually going to solve it algebraically. Here it is, 6x plus y. This is equation number 1 equals 12. Equation number 2, 18x minus 3y equals 18. Let me go ahead and do this one, solve this one by using substitution. Okay, so I do see a nice substitution here. I see that I could solve for y pretty easily right there by adding 6x to both sides of the equation, which gives me y equals 6x plus 12. Oh, I put it in slope-intercept form. That's what we just did last time. Now this was equation number 1, and I'm going to take this y equals, if y equals 6x plus 12, can't I replace the y with that? Okay, so I'm going to now copy this equation down, 18x minus 3 times whatever y equals, and we found out in pink that y equals 6x plus 12. So we replace y with 6x plus 12. All right. Now, be careful with the distribution because you have to distribute the negative sign. Negative 3 times 6x is negative 18x. And negative 3 times 12 gives us negative 36. Now here's where, this is what they're talking about. This is what we got to be careful about. This is maybe a little bit of a shocker for us. But when we take 18x minus 18x, that gives us 0. What that leaves us with is a statement right here. Leaves us with this statement which says negative 36 equals 18. Now we know that that is a false statement. And when the x's or y's or when the variables drop out and you have a false statement, we know that that means no solution. And that kind of thing happened in chapter 1. It's just we didn't have two variables, but the same kind of thing happened. If the variables drop out and you have a false statement, it's no solution. If the variables drop out and you have a true statement, then it's infinitely many solutions in this case, okay? All right, so we took care of that. We actually solved this algebraically, and let's see if that matches up with what was probably confusing here. I selected C because it said solving the system of equations results in a false statement, right? That's what we just found out. Therefore, the system is inconsistent. And you could also think about that means there's no solution. Okay? Solving the system made a false statement. Where was that again? Solving the system made a false statement. Isn't that a false statement right there? Does negative 36 equal 18? No, it never does. That's false. Okay, number 12. Let's go to number 13 now. And let's see if I had space to do number 13. It says solve the system, draw your graph to support your results. Okay, so I don't know if did I give myself space to solve? I did. I added a page here because I knew I was going to be really pinched for space here. So this is going to be number 13. And number 13 said negative 4x plus 5y equals 10. And 32x minus 40y equals 80, equals negative 80. Okay. Oh, geez. Wow, that almost looks like a face. See, look at it. That's what kind of artist I am. No, just kidding. So anyways, if you take a look at that, you can solve by substitution. You can do it. You can do it. You can solve by addition elimination. I want to show you possibly another little trick. And that is, it goes off the idea that whatever you do at one side, you must do to the other side. And instead of multiplying to get these numbers, make them opposites, which you certainly can do. Another trick, like, so for instance, if you wanted to eliminate, let's say you wanted to eliminate the x's. Let me highlight that. Let's say you wanted to eliminate the x's. Well, the least common multiple, which would be, 32. So 32 would be your target. That's already 32, so you'd have to make this one a 32. Okay, so that strategy is just fine. But I want to show you something else that is nice for, it's worth knowing that this is a strategy. And that is when you look at this guy and you see that I've got some common factors, right? What's common in there? It looks like a 4 is common, right? So if I divide everything on the left by 4, it's going to give me a new equation that gives me the same answer. So it just makes the numbers smaller and easier to work with. What's 32 divided by 4? Was there actually something bigger I could have divided by? Oh, wait, there was something bigger I could have divided by. Let's even go bigger. Each one has a common 8 in it. Right? Even better. Make the numbers even smaller. So I divide the left and right by 8, and so I've got a new equation. It's the same as the old one in terms of the answer. 32x divided by 8 gives me 4x. And right here, negative 40 divided by 8 is negative 5y. And negative, right here, negative 80 divided by 8 is negative 10. And now I just copy the first equation down, which just says negative 4x plus 5y equals 10. And look, it's ready to go. I can do my elimination per step. What is negative 4x and a plus 4x? 0x. What is positive 5y and a negative 5y? 0y. What is 10 and a negative 10? 0. So I get 0 equals 0. Now, students at this step will freak out and they just start making up stuff and they say, oh, x equals 0. No. X's and y's just canceled out, right? They just crossed out. The question you want to say is, okay, my variables dropped out. Do I have a true or false statement? Does 0 equal 0? Yeah, I got a true statement. What happens when you have a true statement? When you have a true statement, you have many, many solutions, infinitely many solutions. Now, if you took a Math 100 class at this step, they did the same problem, but they just said infinitely many solutions. But now we are big 120 students, right? And so now we have to say specifically which infinitely many solutions are you talking about? So the way you do this is we write it in set builder notation. My braces are just getting way out of control. I got to slow down. Now this iPad, I got my excuse is the iPad is slipperier than you know what. So slipperier than snot, I think is what they say. But anyways, slippery. And so so my braces are not coming up very good. Okay, I'm cracking myself up here. So there's the brace. And how do you do set builder notation? Well, the thing that we've done in the past, we said the set of all x's such that, but we're not talking about x's here. We're talking about, what are my answers? My answers are ordered pairs. So the set of ordered pair x, y, such that, what is going to give me an answer? Well, any x comma y that works for this either equation. And by the way, I think both equations are pretty much the same equation, aren't they? You might not be convinced of that yet, but as long as it works, as long as your x comma y works for this equation, it'll work for both equations. Now you might say they're not the same. Let me just convince you. What's different between these two equations, right? Well, this one has a negative, and this one has a plus, and this one has a plus, and this has a negative. They're opposites. So what if I came through and multiplied the left side by -1 and the right side by -1? Well, guess what's going to happen? It's going to make both equations exactly the same. That's the point. Both equations are the same equation. They're just kind of disguised. So my solution is going to be the set of all x, y's such that as long as your x, y's make this true, 4x minus 5y equals -10. And yes, you could have put the first one up in here with -4x plus 5y equals +10. But, you know, usually when your leading coefficient is positive, we like that better. But either way would work. Get rid of that. And that's your solution. So let's come up here and finish up. Number 13, the solution is infinitely many solutions, right? Infinitely many solutions. Now, specifically like what? Well, set of all x, y's such that, I got to zoom in here. Dang, what did I say the answer was? Like short-term memory loss. Short-term memory something. I said that we said it was such that 4x minus 5y equals 10. And if you get that, no, -10. (4x minus 5y equals -10). Let me just double check my work. 4x minus 5y equals -10, yeah. Okay, so they would like us to check our solutions by graphing it. I don't feel like doing that, but let's do it. So let's do the first one in green or red. So let's zoom in and see if we could put that in slope-intercept form. I'm going to add 4x on both sides of the equation. This gives me 5y equals, what did I say, 4x? 5y equals 4x plus 10. Now I'm going to divide by 5 on each of the terms. That's going to give me y equals 4/5 x 10 divided by, what was it, 5? Gives me 2. And I'm so dang sloppy here. Let's see. Oh, and then I'm erasing. Divide by 5. 10 divided by 5 is 2. Okay, so this is my first equation that I want to graph. So I graph my first equation, which says, okay, oops, let me zoom in here this way, which says 2 is my y-intercept, goes there. And then it says I go up 4, 1, 2, 3, 4, right, 1, 2, 3, 4, 5. Okay, we go ahead and hopefully I'll snap the line this time. We go this way. And there's my nice perfect graph of y equals 4/5 x plus 2. Let me do my next one, and I'll do this one in green. And we got to make that point a little smaller. And I want to solve for y again. So I'm going to subtract 32x on both sides. That's going to give me -40y equals -32x minus 80. I'm going to divide both sides by -40, -40, -40. It's a little bit of a nightmare, but that's not too bad because -40 divided by -40 is y, so we get our y. And then this little thing right here must be reduced down. Well, we know a negative divided by negative makes a positive, so that's good. But 32 over 40, what's common? Well, there's common 8s, right? So 32 divided by 8 gives me 4. And 40 divided by 8 gives me 5. So it reduced down to 4/5. And negative 80 divided by negative 40 is positive 2. And I think you'll notice that those two equations are the same dang thing. So if I go to my same point 2 and I go up 4 and over 5, I end up getting the same point. So it turns out that when I graph it, right, it's just the same line, which means, remember, what solves a system of equations? It's the points that lie on both lines. Well, there are infinitely many points lying on both those lines. That's why we said the solution is going to be infinitely many solutions, and that was fine in Math 100, but now this is Math 120, and we go a step further saying, well, there are infinitely many solutions, and this equation will tell you what they are. So any x comma y that works for this equation right here will be on this line and be a solution. And there are infinitely many of them because it goes forever, arrows in both directions, right? All right, that was a lot of work. Next one, it says solve the system, draw a graph to support your results. You kidding me? Okay, so now we're going to go ahead and solve it again. And we get to pick if we want to eliminate or if we want to use substitution. This is number 14. I got a little space right here, so I'm going to use this space. I'm going to change my point size. So there's 14. So the system is negative 5x plus 6y equals negative 1. Now 6x is equation number 2 is 6x minus 5y, and that equals 10. There's the system. And I want to figure out, let's go ahead and do this by addition elimination since we haven't done many of those. So let me go red. Probably should have had a little more space here. Get rid of that too, just to give myself a little more space to operate. Go like that. So essentially I've got a 5 and a 6. We'll worry about the sign later. But what is the least common multiple of 5 and 6? What number does 5 and 6 both go into? And that's going to be 30. So you're thinking 30 is my target number. So what can we do to make, what can we multiply by on this top equation to make this negative 5 a negative 30? Right, because I want one to be negative 30, I want one to be positive 30. So it's already negative. So what if I multiply this whole equation on top by 6? So you got to do left and right, correct? Yes. So if I multiply, so what's 6 times negative 5x? That's negative 30x. What is 6 times 6y? That's positive 36y. And what is negative 1 times 6? That's negative 6. Now, down below here, we need to turn that 6 into a positive 30, so we must multiply this 6 times 5, because 5 times 6 will make that target number of 30. And if I multiply the left by 5, I must multiply the right by 5. So 5 times 6x is 30x, and 5 times negative 5 is negative 25y, and 10 times 5 is 50. Now I want to add those two up, and of course, what happened, and it better happen, because if you don't eliminate something at this step, you're not doing anything. You're just writing a bunch of stuff down. Even if you're doing math, even if your math is actually correct, you're not getting anywhere because you have to eliminate an extra y to make progress. So we've got now 36y minus 25, which gives us 11y, equals negative 6 plus 50 is 44. And just like that, we have one equation with one variable, which makes the next step easy. 44 divided by 11 is 4. I've got my y rather. So I've got my y. Now I want my x. How do you get your x? You take equation 1 or 2. It's up to you. I'm going to go ahead and take equation number 1. Let me write it down. Equation number 1, before I started doing all this stuff to it, was originally negative 5x plus 6, I'm going to put a parenthesis, y equals negative 1. Well, the fact of the matter is we know that y is the same as 4. So we're going to replace y with, guess what? 4. Let's do it. So we've got negative 5x plus 6 times y is the same as 4, so y equals 4, equals negative 1. And now I've got one equation with one variable, which is always an awesome thing. I've got negative 5x, 6 times 4 is 24, which equals a negative 1. I subtract 24 off of both sides, and when I do that, I get negative 5x equals negative 25. Divide by negative 5, and let's remember that a negative divided by a negative gives us a positive 5. And we got our answer. We got 5 comma 4 using addition elimination. Let's go up here, 5 comma 4. Solution is, there's just one solution, 5 comma 4. See, you pick this when there's one solution, you pick this when there's infinitely many solutions, and you pick this when it's empty set, which means no solution. Okay, so we got one solution, so we've got to pick A. Now they would like us to graph this, and so graphing, once again, slope-intercept form would probably be the best way to go about it. I can see I'm going to get a nasty fraction with this problem, which is kind of mean of them. But I think we're going to have to go for it anyways, so let's do it. How much space do I have to work here? Not a lot. Okay, let's zoom in, do the zoom in thing. Hopefully we can squeeze everything into a small space by zooming in. So this is equation number 1. We'll do this with red. I want to solve for y, so I have to add 5x to both sides. And when I do that, I get 6y equals 5x minus 1. Here's the mean part on their part, or they just oversight. Divide by 6. I don't care that the slope is a fraction, but I'm not crazy about the y-intercept being negative 1/6 when I'm trying to graph on a little piece of graph paper. But it is what it is, so we'll go forward with that. That's going to give us, right, y equals 5/6 x minus a sixth. Let's deal with that nightmare right now. The y-intercept is negative 1/6. Well, that's 1. And negative 1/6 is if you take that and chop it into sixths. See why I'm saying this is a nightmare? I gotta go, yep. So that means take that 1 unit and chop it into sixths. And we only want one of them, that little guy right there. What a pain. So my y-intercept is right there, and it's going to be somewhat of an estimate, okay? So now, how do I do the slope? Well, you got to go up 5 and right 6. Well, when you go up 5, you're jumping up one whole unit, which keeps on putting you at these, sixth marks. Right? It's a sixth away. This guy's a sixth away from 0, so this is a sixth away from 1. This is a sixth away from... It's kind of it's a mess. Anyway, so this is my y-intercept right here, negative 1/6, and I've got a slope of up 5, right 6. So let's do it. We can do it. Up 1, 2, 3, 4, 5. Right 1, 2, 3, 4, 5, 6. And because they made us have a y-intercept of negative 6th, this is a little bit of a pain. Let's see. There it is there. And that's the best I can do. So there it is right there. Now we need to graph the other one. The second equation. Remember, when you're graphing systems of equations, what's the solution? Well, it's the point where they both cross. Equation number 2, solve for y. We subtract 6x from both sides. Well, this one, they're nice to us again because negative 5y equals negative 6x plus 10. And the nice thing about this guy is you got to divide by negative 5. and you don't know if that's good or bad, but oh, 10 divided by negative 5, that's a whole number, or a integer rather. So that's awesome. We can find that easily. So reduce, and we get y equals negative divided by negative is positive 6 fifths x, and 10 divided by negative 5 is negative 2. So we get y equals, did I put this on the other page? Y equals 6 fifths x minus 2. So this is it. Okay, well, this will be better. I just hope my other one was accurate with that negative sixth. But our y-intercept is negative 2. So go to negative 2 right here. And it says to go up 6 and right 5. So I go up 1, 2, 3, 4, 5, 6, right 1, 2, 3, 4, 5. Hey, look how good I am. That's right on the point. That's right on the money. Okay, so this graph looks like this. Sometimes I even impress myself. And I have to say that because no one else will, so I might as well. There we go right there. And then this guy's right here. And look at that graph. Even with that nasty negative 1/6, I did find the point. There it is right there, the point of intersection. That's the answer. And the answer is 5, 4. I hope that sounds familiar. Is that what we got for this problem? Yay! I was going to have a cow if that didn't work. 5, 4 is correct, and my graph helps me to see that. Now, this no solution, I just want to make sure I wrote that just to describe that's the empty set, and this is infinitely many. That wasn't our solution. Our solution was 5, 4. Okay, let's move on. Let's move on to the, is it the last problem? Are we there? Yes, the last problem. And the last problem's already done for us. Use the graph of the system to determine whether the system is consistent, inconsistent. If it's consistent, indicate whether the system is independent or dependent. All right, well, remember what I said. Consistent means that it has at least one or many solutions, right? And this definitely has a solution. You can see it. You can see it right there. That's definitely a solution. So it must be consistent. So first of all, the answer is either this guy, because it's consistent, it has a solution, or this one. This one, no way. It's inconsistent would be two parallel lines, right? Inconsistent is no solution, so it's not that. Now the next question is it independent or dependent? Well, it's dependent. They're the same exact line. They're laying on top of each other, right? The same exact line, dependent. Independent means they're two different independent lines, and that's what I'm seeing here. I see a pink line and a blue line, so they're independent. So there's our solution. This system is classified as a consistent, independent system. And that is it. We are done. That was kind of long. But once again, this is Professor Gonzalez signing off here. I hope you have a great day and talk to you soon. Bye.